Hello and a warm welcome. Thank you for taking this opportunity to view this presentation. My name is Michael. I'm the Managing Director of Seal Water Technology. I wish to present to you, along with William Smith, a new approach to leak detection, active sonar. We all understand that water loss through leakage is a massive problem, with billions of litres lost and billions of dollars spent on leakage globally. With leak detection being a key pillar to the overall solution, the need for a more accurate, cost-effective solution has never been greater. Currently, one of the best solutions for leak detection are correlating acoustic sensors. Unfortunately, along with other acoustic methods, correlators are limited by the fundamental physics of sound in water, therefore limiting their effective range to a few hundred metres. Pipe materials and poor soil conditions also influence their effectiveness. Given the size of the problem and the limitations of the current methods, we set out to develop a new technology that makes the leak do something, make it talk to us. I.e., how do we make a leak do something for us which we can detect and then use this information to reveal its location. From this, we invented and patented a new signal transmission technology that is long range and makes the leaks talk to us. How do we do this? Active sonar generates a small but intense pulse. This is injected into the water, causing 7.5 kilometers of pipe to talk. The pulse travels down the pipe and interacts with points of interest. These interactions are detectable, and we measure the time it takes for the pulse to go out to the point of interest and return to our sensors. With this information, we're able to calculate the ranges to these points of interest, leaks being one of them. Now I'd like to hand you over to William Smith, our Technical Director.
Thank you, Michael. Hi, I'm William. Now, just to quickly recap an important point, we have made a breakthrough in transmission technology. This pivotal development makes possible the operation of active sonar in underground pipes at unprecedented ranges. No other system in the world can match this performance. Now, this is a photo of one of our units in Australia. It's been tested by Ying, one of the inventors. In the background is one of the scans. Over here on the left-hand side is where the transmission has been injected into the system. The returns quickly settle down. You can then see a succession of negative pressure events. These are very high signal-to-noise ratio echoes from T's, fittings and pipes. We also get leak data out of those. Significantly, this is 7.5 kilometers from both directions of a pipe, singing with data and noise. No other system in the world can do that. In summary, the pipe talks back to us with a data stream once we excite it. Now, looking at the first half of that data, over here on the left, you can see where our transmission wave goes in. The returns quickly settle down, and emerging out of the confusion, we see a whole lot of negative half-wave cycles. These are echoes from T's and fittings and so forth. This first big one is a Sugars Road intersection. That's a major intersection. I'll lay this on a GIS map on the next slide, and you can see how that fits. Further over on the right, we identified some acreage properties. These are like those little hobby farms there, each fed with 1-inch pipes, and these show up really clearly on our system as well. Now, what's interesting about those is you can see what a normal return looks like. So these are all normal except for this one in the middle. What's going on there? Well, that's what a leak looks like. That's our business. So we're trying to find these anomalies. This is what the scan looks like overlaid onto a GIS map. So we did our scan. We installed the instrument at the top of the page here. Some of the transmission went left, some of it went right, and that hit a major T intersection here. Some went up the page, some went down the page. Now here is the Sugars Road intersection that we pointed out on the previous slide. From here the pulse went into 3 directions, and the portion that travelled to the right, it gave us a very nice set of returns from the 1-inch pipes that service these acreage properties. The leak we found was right down next to this intersection here. So we went out to the site. We, having identified the tee off where we suspected the leak was, and we did in fact verify a fairly substantial leak. That was later excavated and corrected. Now I'll point out this was 3.6 kilometres away. It was in plastic pipe, and the pipe material has no effect on signal strength. It remains strong. It doesn't attenuate the way sound waves do. So at this point, thank you very much. I'll hand back to Michael.
So where are we? Our technology can identify leaks, T's and elbows. It's long range. We can detect out to 7.5 kilometres. Importantly, it works equally well in all pipe materials. The system does not disrupt or damage networks. The inventive step and the physics are established. Backing this, we have a very strong patent with 23 claims registered, making this truly a unique solution. So where's the value in all this? Say for example you had a 10-kilometre section of pipe. We would take 4 to 5 readings to survey. Acoustics, you would need to take 30 plus readings, equally spaced out, assuming there is access to the pipe. With our tech's ability to survey long sections of the pipe along with a 15-minute setup time per reading, labour costs per metre surveyed will be significantly reduced. A DMA, 5 kilometres by 5 kilometres, would require hundreds of real-time link sensors in situ. SIL-Tech, 10 to 15 units strategically located. We also see our technology fitting in and enhancing other monitoring technologies. We're in the final stages of a standalone unit. Development has already started on a monitoring unit for permanent installations to work in conjunction with existing smart networks. Parallel to all this, we're developing various software packages, feature recognition, map plotting and reporting. Proof of concept trials will be conducted in the UK, US and Europe. To expand the business, we need to forge partnerships with industrial leaders, utilities, leak detection companies. Revenue generation will be through licensing and subscription agreements. Behind all this, we have a very strong team, headed by Dr. Duncan Hewell-Evans. He's the original inventor of the concept, supported by Ying Lee and William Smith. Other key members, James Bess, Dr. Leonard Kasser from the University of Pittsburgh, myself and Dorothy Nashe. Thank you for taking the time to watch this Seal Water Tech presentation. I trust this brief introduction has provided a clear understanding of our breakthrough water leak detection technology. Thank you.